Hey everyone, thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome Stephanie Horbaczewski and Gunjan Bhattarai from Vody. We've been following on with Vody for a long time at Weaviate. They're building all sorts of super exciting things with multimodal AI, combining different modalities from text and images, this kind of idea. So this podcast is going to dive all into that topic and learn about what Vody is working on. So Stephanie and Gunjan, firstly, thank you so much for joining the podcast.
Thanks so much for having us, Connor. You were one of our first startup friends. We're really excited to be here.
Yeah, thanks so much.
Awesome. So could we start off with the story of Vody, the problem it's solving and the founding vision?
Yeah, definitely. So I'm a second-time founder. My first business was a $100 million a year business on top of Google and Facebook that worked entirely with unstructured data. So when BERT came out, I grabbed a couple of my technical team and left, invested some of the money I made, and started a research company. We did 3 years of projects working on embeddings, worked with Comcast, HBO, moved into retail with Nike, and then spent a year developing our product with Wayfair.
Wow, amazing. Yeah, so if we could unpack that a little bit. So you were already working with kind of unstructured data, you saw the BERT revolution, and then you instantly said multimodal is next, I think, or was it you grew into multimodal?
What really happened is I said recommendations are bad, and why? I didn't understand. I felt like there was a ton of data, and it didn't make sense to me that we were returning such poor recommendations. Which is when I discovered that what a customer is using to make decisions, for example, images, Q&A, reviews, structured data, is not what's being used to make those recommendations. And so I thought if we could bridge that gap, we're going to have some really transformative experiences in e-commerce. And so we set out to build those specific models, fine-tuned for the e-commerce media space, multimodal models to use all of these different types of data.
That's so interesting. I've been like dabbling with recommendation and building kind of like apparel recommendations to illustrate our ref2vec feature, which is a way that we've built in to have recommendations with embeddings. I recently at ODSC East listened to Madhav Thakur describe how they use embeddings at Shopify for recommendation, and his explanation of the business impact of that was incredible, and understanding the scope of it. So could maybe is leaving on the business CEO hat, you described new experiences with recommendation. Can you kind of unpack that a little more?
Yeah, I mean, what's amazing about the embedding is it's bringing all of the understanding about a product. So, a real complete human level of understanding is going back to your model to make a recommendation. So, when you're looking for a fuchsia chair with wooden legs, there's not enough data labeling in the world right now to do that. But if you have an actual understanding of the product, and so Gunjan, maybe you can talk a little bit about our multimodal product embeddings.
Sure. So I'll go a little bit further on the fuchsia chair and be like, most models simply don't even have the capability to handle that today. And so some of the core concerns of that is, for example, one, you have to detect color in a image, and that involves vision. At the same time, though, there may be multiple objects in an image. Maybe there's something specific in that image you want the color of. And so you sort of need to be able to guide the model as to what you want, and that would involve natural language. So that's one of the core opportunities in multimodal. Previously, we'd only have some understanding of how things might look from an image perspective or a text perspective. It's like someone who was previously illiterate but had perfect vision, and then some person who had a PhD but was entirely blind. And so we're able to combine these two extreme forms of knowledge into one person and basically have a model that knows all the latest advancements in science and technology and like all sorts of disciplines, but is able to actually see and understand how the world looks like with their own eyes. So multimodal embeddings essentially deliver on that promise. So the idea is that products are multimodal in nature. They have textual features, for example, product descriptions, product titles, reviews. They have images, namely the images that you're trying to have someone sell for, and other details too, like various metadata fields, things related to what other products people buy, maybe some product videos, lots of other things. And so the idea is if we can jointly align these types of representations together and be able to have a model that understands all of these, we're able to have embeddings that are able to understand these products really well and can understand what's similar, what's different, and then people can build models on top of them and build search that's able to leverage that newfound understanding.
Fascinating. I want to park the topic of the color tagging thing. I think that's really fascinating. This idea of how you kind of like use classifiers to extract metadata from unstructured data. That's definitely a topic as we go into the weeds further. I really want to understand Vody a little better. So this decision to do custom embedding models, that's a really unique angle. I think I've seen, I think OpenAI and Cohere, they offer a custom text embedding model. Right now, I'm not so sure that the tooling on doing a custom embedding model is all that strong yet. So it does seem like such an interesting market category to go after. Can you explain a little further this kind of, you know, custom embedding models for people, what that kind of looks like?
Yeah, so to get these amazing, incredible open source multimodal models ready to be used in production in an environment in e-commerce, you have to do a lot of things to them. So you have to build extensive data sets very specific to this. You have to build different architectures for these different modalities, optimize them for them. And maybe Gunjan, maybe you can give them a few highlights of what, for example, we did with our first model.
So essentially, with our first model, in order to make these embeddings work, we had to first understand, okay, these open source models are really good at, say, generic images and text, stuff that you can find easily in the internet, stuff on Google Images, basic stuff. The problem, though, is that these companies usually have very specific domains they work in. For example, e-commerce companies like Amazon or Wayfair have very different requirements of what they want a model to look like than maybe standard Google or Microsoft, because e-commerce is inherently different from standard multimodal. And so a model would need to be domain adapted to be able to understand what these types of products look like, what text when you try to sell a product looks like, how products look like, the prices of these things. Basically, there's new details that these types of models don't understand. And so one of the most important steps is to domain adapt these models so they are able to understand e-commerce at a meaningful level. And this can be extended to basically any industry, real estate, AR, VR, plenty of others. So that's one of the most important steps as to what these businesses need in these types of multimodal embeddings. There are other tricks too.
Yeah, let's give you some examples. You will give a few examples. Understanding what life stage your product is for, what room you might use it in, what style it might be. If we look ahead to what you're going to do with multimodal LLMs, imagine being able to go to an e-commerce site and generate a style blog about how you might style this item, particularly in your house. This weekend, Jonathan and I spent a bunch of time on Midjourney and ChatGPT. Um, in essence, creating a way to style some different ways to do our house. And so, that's really going to be part of your new e-commerce experience. You're not just going to buy the products, you're really going to be able to understand how to use them in your life. And it's going to be really incredible.
Yeah, that paints such a compelling picture. That kind of, I've seen like these room GPT things on like Twitter and stuff. It sounds like that kind of idea, and we're gonna come back to that. And maybe as a thing, if you're listening and you want to skip ahead to that, you can see the chapters in the video. But I want to stay on this custom embedding models a little further because I think this is such a deep topic. Like as an example, I like to kind of play with Weaviate by taking these podcast transcriptions and putting them in Weaviate. So Stephanie and Gunjan, you'll soon be in my data set. And like I find with this that yeah, like the custom text embeddings are getting me way better search results than the off the shelf, any of the off the shelf models because of this, this specific conversation we're having as we start saying things like room GPT, clip, instruct, blip. We start saying all these these keywords, and it's like the models, the domain adaptation to them. Can we unpack that a little more for like the multimodal e-commerce case? Like say I'm like Aloe, like a like an apparel brand. It's like the particular style of my clothing is that you're gonna start fine tuning the embedding models on the descriptions of the yellow shirt with the yellow shirt, and then that kind of leads to better search. Is that kind of the general thinking?
Yeah, so I think how you're going to use this is a good way to answer that. So by creating first an embedding of the product using all of the data you have, so you have this human level of understanding about it, putting it in your Weaviate database, and then eventually creating an embedding of the search query from the user. And so now you're matching up exactly, semantic search, exactly what they mean. And let's take it further. When you want to start searching and say, "Oh, I really like this shirt, but I want something brighter, and I want it short sleeve," and it understands what you mean and is able to identify that. Or our COO was just looking for mixed drink maker, and he discovered as he looked through them that he wanted it to work outside, that he needed it to be able to handle alcohol, and being able to revise and have it understand that you've made these new new decisions about how do you want to search and how you understand the product. Gotcha. Maybe you want to talk a little bit about that integration, the use of those two sets of embeddings.
In order to combine these embeddings, essentially, well, first, where are you going to use these embeddings? So in the case of something like product search, you have two options. Essentially, the core problem is that search is very, very speed dependent, and any and every speed optimization is going to be essential. And if you're even a second late, your business has lost millions of dollars of revenue. And so the things that need to happen is you need to take these embeddings. Usually, you're going to take your products, get embeddings of each of these, cache them, and use them in some sort of vector database, like, for example, Weaviate. And you can use those embeddings to be able to figure out what products are similar to each other. So you can therefore say, do on the fly recommendations to your customers with your website. So that's one valuable way in order to do integrations. Of course, there might be other ways, like if you're doing an offline application, maybe, for example, you want to use these embeddings to train a model, as Steph noted, to detect the style or what room this product might be in. And so that might just be something where you do a data labeling task offline, use this model to add additional information, pass it into Elasticsearch or Cloud Search or other types of services like that, and essentially be able to use that information on your existing search without changing anything. So the integrations are going to fundamentally depend on the use case. In the case of e-commerce, speed is usually paramount, and so that's going to affect most of what you're doing, but essentially it doesn't look too different from how unimodal models like in text or vision work within the e-commerce space. It's just dumping in a new model, and everything you would have used before would be what you would use today.
I think there's a great example from the project we did with HBO that a consumer will really relate to. I loved Queen's Gambit. If I go to HBO and I say, hey, can you show me what you have that's most like this? Because they're using interaction data and very limited structure data, they don't know what I mean, right? And so building an embedding of all film and TV shows, what we did, we were able to work with HBO on how would they make recommendations about data that they have no interaction data on. Well, they have a complete understanding with thousands of topical and emotional attributes. Then, these embeddings understand the movies the way you and I do. Next, by the way, very exciting would be to embed the movie itself. But you could use those embeddings, initialize your model originally as the content understanding, and then no matter what we searched for on these platforms, we'd be able to see what they have that is most like that show.
So kind of staying on the movie example, it reminds me of like so I think maybe there are two things here. There's like where you are labeling the categories as well as just the embedding by itself, as you meant, like the next step being the embedding of the movie itself that just captures all the semantics, compared to where you like classify each label and then that becomes the vector. It sounds like, so if I take a movie like Deadpool, right, that's like action and also comedy, so I have those two labels, and like it's not horror, right? Like, yeah, and making that label. So that's how you then bootstrap like a collaborative filtering kind of thing, where you recommend like in that kind of way. So it sounds, yeah.
Yeah, bingo. Actually, genres is something none of us can agree about. We can only agree on two genres. So that's an example where, while that seems like helpful structured data, it actually isn't in making recommendations due to consumer bias and how they have different opinions of what's funny.
So a lot of it is training classifiers then as well, right? Then, because it's not like the contrastive uh, image. Like I usually think when I think of embedding models, I think that you're contrasting it compared to this. Sounds like you're producing classifiers. Is that correct?
Both. So it seems that the community has largely coalesced around using some sort of contrastive loss function in order to create embeddings. So, for example, sentence transformers, NLP based, is done based on contrastive learning. And you might also find something like clip or blip or slip or all those other alternatives. Those, I mean, they all use the same naming convention. So essentially, all of those use contrastive learning in order to align image and text embeddings. You can extend that to other modalities as well, like including video and audio, like what you might want to do in the context of a movie. So contrastive loss is still going to be a key part, at least in the state of the art that I'm aware of. Classifiers matter too, in that the way that you can also structure this contrastive loss as a classifier. Like if you want to do using a momentum queue, you can style it that way. Classifiers also matter, for example, if maybe you have a lot of data that has a classification label and you want to use that in order to inform your learning. For example, maybe you know that these types of products belong in this category, or I guess in the context of movies, the type of movies belong in this genre. This other type of movies belong in this different type of genre. And so you can use that to sort of partition these embeddings away, and that can also be used. So I think mostly it's a contrastive problem. Classification is a way in order to get more data to help. You can structure said contrastive problem as a classification one, although it's one option out of many. Contrastive is a really big problem. And of course, you can fine tune many of these embeddings in classifier type problems, which we anticipate would be a massive use of these types of embeddings. So, kind of all the above.
Yeah, really. So I think we're starting to unpack the meat of how the training happens and the fine tuning. So I guess my first question with that is the thinking around, like, fine tuning from a foundation model and that kind of thinking. So does Vody, do you take a pre-trained model off the shelf and then start fine-tuning it for HBO, Nike, or do you train your own, like, kind of foundation model where you pre-train it on a massive amount of data set? How are you thinking about that kind of thing?
Yeah, so we build our own data sets. We have huge data sets for this purpose. And we are building fine-tuned models that are zero shot off the shelf. So you can come and take them. There are still a lot of hurdles, as you know, to overcome in the data space. And so we are making it very easy for our clients to come and take them off the shelf. We build our own models and we fine-tune others. Particular shout out from me to Junan Lee and Stephen Hoy and the team at Salesforce, authors of Blip. We think their work is super imaginative and love working with it. But we work with all models. Gunjan, maybe you want to talk about some of our most recent architectures.
Sure. So I've built a bunch lately, and so essentially some of this might involve, for example, trying to fuse models together. Like for example, images and text. You want to fuse them. You can either fuse them right at the beginning or at the end when you build a model. You can say have some sort of clip-like architecture where you're not fusing them at all. You're basically just training two separate models or multiple models if you want to extend this to additional modalities, and basically have them all represent similar ideas that are represented in text or image or some other modality. That's another option. You can also say combine these types of ideas first, use this alignment before then fusing those together. That might be helpful. Like, for example, if you want to do a primarily image based task and you want to use the text to help guide the image model to an answer, that is another alternative. It really does depend. I think most of the decisions end up being dependent on client specific needs. Namely, for example, say how fast the model needs to be, how much memory you can use, how accurate does it need to be. Those types of trade offs are mainly where most of the custom model building happens. Because unlike an NLP or vision where there's like so many models and you can use them for like every specific use case, there's like a super small, quick version that gets the job done. There are gigantic models that get you accuracy and pretty much everything in between. But multimodal is so nascent and multimodal has so many different modalities that there simply doesn't exist anything like it in open source or even closed source at this point. And so we have to build those out.
A couple domain specific examples. Most vision models take an average, which if you're talking about a flower or a liver is a great idea. In e-commerce, it's not. Usually the first shot is the product. By the time you get to 3, you've got a detail shot. Maybe you even have a size chart, right? And so taking an average no longer works. One of the important things in the e-commerce is you can't have to retrain this model every time you update your catalog. Some of these guys are updating catalog, literally hourly. And so they need to work. And so there's a lot of, maybe Gunjan, that's interesting to talk about, maybe some of the instruct blip work to do that.
Sure. So if we want to talk about instruct blip, essentially that would be sort of like taking these ideas to the LLM space. So GPT-4 proved that it's possible to build a multimodal LLM that takes vision as input or text as input and is able to generate text based on that. There were other types of works before that, like Flamingo and plenty of others that don't come to my mind at the moment, but since GPT sort of generated this new generative wave, no pun intended, there's been a lot of other work to try and say replicate some of those innovations. And one of those was Instruct Blip, which first tried to train as efficiently as they could a way to take vision as input and be able to generate text based upon it in the LLM world. And then InstructBlip was like, okay, let's go take every academic data set we can find, turn it into instructions, and teach this LLM that knowledge so it can then generalize to new tasks in a zero-shot setting that we previously may have not thought about. Since academic data sets only cover so much, if we have a model that can generalize sort of like ChatGPT can, then it can do a crazy amount of things. So that's the essential idea. It is definitely in Vody's interest to be able to produce something like that in the e-commerce space. And further compounding that is the fact that every different company in e-commerce, or say in the case of film and TV, have different things they want to do a model with. And so their tasks are going to be fairly company to company. That's a problem for us since obviously this isn't a consulting firm. And so as a consequence, we want to build stuff that generalizes really well to other firms. And so this type of instruction tuning and having really good zero shot performance that can generalize to new tasks that nobody at the firm even thought about would be really important. The idea of using instruction tuning to generalize to new sorts of tasks is something that allows for scalability. It allows for this model to be used in many different cases and makes us really excited about the potential of what these models can be used for.
Yeah, without question. So there's a lot of information that quickly, Stephanie, you mentioned the re-indexing as you update the catalog, and I just as to just pull that nugget out of the podcast for people listening, that's a huge problem. Re-indexing, I think we see that all the time, and just something to tackle. But yeah, I want to stay on this. You mentioned GPT-4 being able to handle multimodal thing. We saw papers like you mentioned Flamingo. We saw Frozen, this paper that was called like pre-trained transformers as universal computation engines, basically that you can just put the image embeddings into the latent space of GPT-3, and then it seems to be able to just instantly be able to reason across the embedding space, which is quite astonishing. But then, yeah, so I mean, this idea of foundation model training is so interesting. I think at the time we were recording this podcast, Cohere has just announced raising like $270 million, and so this space is emerging. So, do you think that the foundation model providers for multimodal, whether it's and there's two things I want to parse out quickly. So there's the generative models, the multimodal generative models, and then there's the decision to train embedding models versus generative models, embedding models versus generative models. So can we start with do you think the multimodal foundation generative models will be different from the text models?
Yes, namely because they're going to have a lot more capabilities, right? So, for example, yes, you can say use clever tricks to try and pass a purely text model information about an image. Lava, for example, basically is able to get surprisingly good performance from ChatGPT, which has never seen an image before, by passing some context on the image, like a caption, as well as, say, bounding boxes, determining what every object is there. And the model is surprisingly good at creating data and generating it, which is helpful, except there are some limitations of that. For example, one, what we found is that using an object detection based model ends up slowing things down a great deal. It's not efficient. One paper called Wilt was able to remove that part and claim a 60 times increase in speed from doing so, which is super impressive. And there's also the idea that these types of multimodal models, because they're able to learn from each other, are able to get a much more vivid picture that is able to integrate these two much better than, say, what a text model can do with, say, some clever ways of injecting image information without training it. So, for example, bring back in something I talked about earlier in the podcast. We have someone who basically only has seen images like with their own two eyes and seen the world around them, but is illiterate. And then we have someone who is blind and basically has the knowledge of like practically every PhD in the world being visionary. Those two collaborating together is going to be a very difficult way to like work together. They're not going to be nearly as good as if one person had those capabilities together. And the idea behind having a multimodal model is you want to have that one superstar person who can see the world and know everything about it and have the knowledge of all of Wikipedia, as opposed to two people with these extreme split apart skills trying their best to collaborate. So that's the opportunity in multimodal. Being able to combine those two together instead of just limping your way with two extremes.
Exactly the way you are as a consumer, Connor, right? When you're looking at buying a product, you're understanding that structured data, the price, et cetera, while looking at the style and the image and what it's going to look like, and you are processing them in the same space. And so it's the same idea.
Yeah, brilliant. I agree fully with that. That certainly there's something to be doing the multimodal optimization. I think just that putting image embeddings into a text model, the fact that that works at all is already pretty astonishing, right? And
Yeah, I was surprised. I would have never guessed.
yeah. Yeah, and I think, like how could you have a good sense of audio, or like how songs sound from a text space? It doesn't make any sense. So certainly, like that example is obviously visual, and that makes sense too. So could we take apart that other thing, the decision to train embedding models versus generative models in this space of being a foundation model provider?
Yes, building a model library. We actually have a model roadmap to do all of the things we're talking about. I think probably the answer to that comes more from the startup enterprise meetup, which is what is the more pressing need, and right now we're building the models so that they can get more out of the models they've already deployed by including more data in them. And so while working towards sort of the future of introducing some of this, like a multimodal LLM, and the product features you would need to build to support that model on the site is even different than the work, right?
Yeah. So essentially, embeddings in generative tend to serve two key different purposes. Embeddings, well, has a unique advantage of you'll be able to build services on top of them without changing it. Like if you want to do product search and recommendation or movie search and recommendation, you can use these embeddings, do semantic search, be able to cache them in a vector database so that you can do efficiency gains. And that tends to be the best way to do things in sort of speed limited applications. Um, Embeddings also have the advantage that you can train task specific models, have much more smaller ones that are faster, and that would be the core advantage of embedding based models. Generative models tend to be much larger, they are much more generalizable, are able to do a crazy amount of stuff that even people who are well familiar with them still get astonished with every single day. And that is a valuable advantage of them. So they can do crazy things, can generalize to a lot of things. If you want to like cover some new task you didn't think about, these models can do that with astonishing ability. So that's the idea behind generative, being able to generalize to new tasks, have crazy good performance, and sort of like hit that accuracy frontier for customers who care about it. For embeddings, we're most sort of concerned with more traditional applications, speed related things. And so it's sort of like a dichotomy where different customers are going to want embeddings and different ones are going to want generative, just depending on what their specific use case are. They don't really overlap simply because it seems that most businesses have very specific KPIs they need to hit, and they tend to already be pretty demanding on them. And one does not really work for the other, and vice versa.
Yeah, it's so fascinating. I think like a couple notes I had for firstly, I was thinking about how we're talking about kind of classifiers as well as sort of the more open-ended like similarity search or generative. And I think there's this paper called Set Fit, which is about how you fine-tune embedding models for classification and it's more efficient. And really efficiency and the cost of these things, that's the big topic I want to stay on a little further. I think training embedding models generally aren't that big models. I think the OpenAI Ada, they have some embeddings that come from that big model, but I think mostly embedding models, they're not big models, correct? Like, like around 100 million parameters is the typical scale we're talking about. Is that correct?
You could go a little bit smaller than that too. The most popular one in Hugging Face is like the smallest mini LLM. It's like a 21 million parameters. But you're right. Essentially, embedding models tend to see saturation. I think you don't get more than 300, 400, but honestly, it's been a long time since I've checked the Hugging Face leaderboard. And so viewers are more than welcome to go check and figure out what the true numbers right now. But there seems to be a saturation point where you don't really get better embeddings after getting beyond some specific model capacity, which suggests that embeddings are not necessarily that difficult, relatively speaking, for a deep learning model to learn. And so, but they don't really get any benefit from additional parameters. Generative, on the other hand, keeps on going better and better for as large as I've seen. I haven't seen like any saturation point in generative yet. Maybe some people at OpenAI have found something. Maybe that's why they haven't gone past 175 billion. Although maybe GPT-4 is larger. I don't know. Maybe someone does. Would love to know. Um, but yeah, it's just that embeddings tend to hit a saturation point where they don't get better. Probably because embeddings and understanding something is a much easier task than being fluent in writing entire essays on some really random topic, which ChatGPT does great.
Yeah, that to me is just one of the most interesting topics because like if you're someone who's been studying deep learning for the last few years and you have all these skills around like training models and ML ops and all that kind of stuff, I think training embedding models is the opportunity because they're smaller scale. You can apply all the clever training tricks, like as you mentioned, like programmatic labeling and knowledge distillation. This is more of an opportunity to apply that. And so this brings me into kind of like my hot take. We'll see how well this ages. like I, I've been thinking a lot about like this new class of like zero shot, the retrieval augmented generation kind of pipeline where the reasoning part and the search models, they're like separate, and you don't think about training the zero shot reader model, and you only would think about training the search models. Do you think that that kind of paradigm that will be the way going forward? Because like I guess the alternative view is that as it's getting cheaper to fine tune the language models, we'll say like the LoRa, low rank adaptation, this kind of thing, that the thinking is you don't even need to do retrieval augmented generation. You could just, fine tune the language model or, the multimodal generative model on your particular domain compared to this other setting where you're just updating the search models and you keep the zero shot generative model fixed. Do you think that'll be the way going forward?
So, I mean, there are very easy ways to build that today, and is something that's going to be very common in applications. I myself have used that to great effect, which has been very fun. I'm leery about making predictions of what happens going forward, since honestly, my track record of predicting the future is less than I would like. I would be persuaded that a retrieval based augmentation system would help. For example, Bard is using that. ChatGPT in their Plus form has used that through the form of their plugins. And it seems like people are going in this type of direction. I think in this case, you're more talking about situations where you have a bunch of documents or a bunch of products or a bunch of movies, and you sort of want to pick the one that's most relevant to feed into your LLM or whatever is doing this generation. And that I think is going to be valuable as long as, say, attention remains expensive. And there have been some massive innovations in the space for the last 4 months. This has been something I've been following really closely. I've seen more valuable stuff at an exponential pace in the last 4 months than I saw in the last 3 years. And I'm just astonished. And so maybe these types of things may become less relevant as attention becomes more efficient and can generate up to like 100,000 tokens, 200,000, and these types of crazy numbers. But those are also complicated to build out, and I don't see these systems integrating that for at least a few years, thanks to the fact that diffusion of innovation takes a while. And so maybe that, because of that, I can see this type of paradigm being useful for the next few years at least. And even with like these efficient form of attention, they are using retrieval as well. So they're trying to retrieve from a database in order to try and make things more efficient. So maybe even the future of attention, which is supposed to solve this problem, will literally be using retrieval in order to solve it. So we might see it just go in a different way. We'll just change our idea of attention. And I think retrieval is valuable, and maybe that'll even become the future of attention. I'll just stop at that.
Yeah, there's quite a lot. I mean, like there's like if we want to like staying on this topic of like the retro models where you're doing like fusion encoder and you put embeddings directly into the attention layer, and I think we also took our top, like there's like the LoRa, there's like the sparse fine tuning that just makes it easier to fine tune the existing language models, and then we're coming into like these new models like Mosaic's MPT or the Anthropic Cloud that they are designed to take massive input windows, and I think that complements retrieval quite nicely. But sort of stepping outside back into our recommendation hat, I'm curious with this perspective on recommendation with embeddings, and then because the way that I see recommendation, that it's typically been done by these symbolic ranking models where you take like features about Connor, like male likes basketball, maybe that's a feature. I like basketball, but like, and then you would have features for each of the Nike products, and so you would feed these into like XGBoost and rank them. Do you think those kind of models are still valuable? Does Vody think about training those kind of models?
So I do think they are valuable. For example, one focus of ours is to look at structured data fields, seeing they have a lot of context, and those structured data fields tend to align quite nicely with, say, person is male, and like these specific types of like, well, I'm in an LP at heart, bag of words types features. So essentially, I do think that's still going to be valuable. I think at least in the context of e-commerce and maybe like things like Netflix, um, it goes beyond, say, content-based embeddings, and you also have to start considering what other people want, and that would, or what people want and what similar things are, what similar movies, similar products. That tends to be really valuable to do recommendations in this space. And so I think recommendations are going to be heavy on that. But in order to even process and understand that information effectively, your model needs to have the full picture of like how to use that information. It doesn't matter if you have like a billion like clicking of your movies if say you don't know how to use them. Like if all I know is movie name title and I'm trying to figure out clicks of like a billion from that, I don't have much information to even like find patterns. But multimodal broadens that scope a lot, and now I can use say specific parts of that movie. I can use images, the trailers, the entire transcript. Now I'm able to broaden what I'm able to use to process those people, that like a billion people that clicked on your movies, to be able to make recommendations. So this doesn't really change the fact that seeing what other people want and seeing how similar you are to other people, that is still going to be valuable. But what multimodal allows you to do is be able to take that information and use a lot more of it than you were able to previously. So broadening the view.
Yeah, I think well, yeah, for sure it seems like the embeddings from the products alone can get a lot of that symbolic data out of it, and then it's getting so good that it captures it all. Like if I click on a few pictures of like I'm on Nike and I start clicking on like LeBron James shoes or like a Kyrie Irving t-shirt, and now it can pick up on all these other kind of features for me pretty quickly. So earlier we mentioned RoomGPT and that we'd come back into that topic later on. So I'm tagging it now. So this kind of idea where you know retrieve and then generate like personalized retrieval. So you know I take Connor and maybe using the Weaviate RefDevec example just because this is how I think about it. But you know like I'd have Connor and I like this you know LeBron James shoes, Kyrie Irving t-shirt. I average those vectors and then that's the Connor vector. And so now I like search for the new products, and then I would feed those new products into like a generative model where it's like a picture of me and it like you know puts the shirt on me, stuff like this. How are you thinking about that kind of like you know personalized generation? I hope I set up the question correctly, but this kind of thing where you like to come back to the Room GPT, it's like I take a picture of my you know my living room, and then the new products come in as a big catalog of like 1,000 Wayfair you know tables and stuff, and then first it ranks it by using the Connor vector, and then it puts it in my room so I can see what it would look like in my living room, that kind of thing.
Yeah, so I find RoomGPT interesting more so because it uses ControlNet, which I found interesting since you're able to condition that generation of, say, what you want a room look like and be able to better control how, say, your text to image model works. That I find as really interesting. Of course, this is relatively nascent and ControlNet is a relatively new model. I mean, I think 1.1 came out recently, but so I think it's going to be a very interesting space going forward. I think there's going to be a lot of innovation. I think it's cool right now. Definitely in the context of say e-commerce, you will want to like when you know what room something wants to belong in, maybe there's multiple valuable rooms that a object might be relevant in. Like lamps can be in different types of rooms. And so if you can use this sort of like text to image generation with ControlNet, or I guess more generally Room GPT, you'll be able to, or a retailer could easily just take this and change their lamp in a living room to maybe a lamp in a dining room or in a bedroom, all with using a simple model. And I'm sure that would be a very valuable place for being able to sell these types of products in a way that more is customized with customer needs. So I think it's really valuable. I think it's really new research, and I'm excited to see, say, what's going to happen in the next few months because I think a lot's going to happen.
I think you'll be able to index a little lower on personal information, right? So like we won't need to know as much about Connor if you're putting in a room and you understand so much more about every single product that's in the room. And if you're saying, hey, what could I put on this wall, right? You'll be able to use so much more context from the image itself and rely less on the user. You know, Netflix does some incredible work with embeddings. If everybody wants to read more on their blog, you know, and they're able to look at viewing patterns. So you know, again, thousands of topical and emotional attributes and say cut different trailers to show different audiences, reorder. They're even personalizing the order you see carousels in, right? By using all this information. So it's not as reliant on you know particular user data, but on how much more data they can use to create these experiences.
Yeah, that I think that paints such a compelling picture, especially because you know if you no longer need to have this treasure trove of data, right? Because the zero shot model from Vody can look at the picture and then extract all the, as you mentioned, like if it takes a picture of my living room, they'll see my other furniture and like get a sense of my style, I suppose. Like, Yeah, as because it sounds like quite the business change. Like if I'm like, I think a lot about this thing of like who should implement search. Like should, Allo that I mentioned earlier, should they be thinking about like we should have our own, we should control our own search on our website, or should we like use Amazon? I think in the past you'd want to use like Amazon or these big players because they had all this interaction data and that was like the only way to do it. But now because of these embedding models that, as you mentioned, can just take a picture of you and get a sense of your style instantly, do you think more brands will be thinking like, I'm cutting out the aggregation platform, I'm going to, you know, build this right into my website and manage this kind of advanced technology myself?
Yes, my answer to that would be two parts. One is like the distribution channel, the fact that they have the audience on some of these bigger platforms is sort of one piece. But when you flip to the side of being able to control more of their own on-site conversion, 75% of revenue in e-commerce is lost from abandoned shopping carts. So if you don't know you have duplicate products you're showing a user, they're gone. If they get confused about what they're looking at, they're gone. Right. So I think being able to use all of their own data that we're using to make purchase decisions to personalize an experience for us, they don't need to know as much about me anymore. They now have use of the data that I was using to make the purchase decision. So I think it can really, transform how they personalize your home screen experience to how they show your objects. I mean, I imagine one day where they know I bought this shirt, so the next time I open, skirts, I'm seeing it with this shirt. So now I'm imagining my own closet, right? Like you can get to that point where you can kind of mix the personalization with what we were saying earlier, which is not needing it because you have such a great understanding of the product, so you don't need to know the user as well.
Yeah, I agree. That's I hadn't thought about that before, but that is cool that it like it has your closet, and so it can orchestrate it that way. See what you're missing from the closet, and yeah, I mean, it's like I'm curious about this kind of it's more of a technical topic, but this kind of like diversity and recommendations and how embeddings achieves that, because these models are trained for similarity and to show you similar things to what you purchased. So how would a system work that shows you some things like, because like a lot of experiments with RefDivec, as I mentioned, like we're averaging the LeBron James, Kyrie Irving stuff. We average that vector, and so we're just going to get that. How do you think about diversity and recommendation with embeddings?
Yes, so think about like cart filling. Like now that you have an understanding about the product, let's look at somebody like Home Depot or Lowe's, right? Now that you have an understanding, you don't want to show them more hammers or different hammers. You want to show them nails. You want to show them whatever gloves you'd use, whatever other tools you use with the hammer. Right. So some of that understanding.
Yeah, I think you can get diversity from a lot of different ways. So I guess if we're talking just about embeddings and like these types of encoder only models, so to speak, you can achieve this by, for example, changing up dropout a little bit. You can sort of like maybe provide some sort of like noise context to these types of models, which I don't think is something people do, but is entirely something that's like theoretically possible if you want to take the idea from like GANs. So that can help. You can also change the way that you're doing similarity. Maybe if you want to, you're taking the top 20 most similar things rather than going 1, 2, 3, 4, 5, 6, 7. You can sort of like switch up that order. A lot of people use like a bi encoder, cross encoder type framework, and just changing up the way you use that might help, adding more context. So you can create diversity recommendations simply by changing up your inputs, maybe changing up the model a little bit, or even like changing the way that you like post process things. So getting that type of diversity is something that you can pretty much tinker with at pretty much every stage of this overall recommendation pipeline. And so ultimately, I think that's something that's going to be up to, say, the individual users, like the companies that are integrating these models and these pipelines into their products.
Yeah, Stephanie, you mentioned like baskets, and Gunjan, you also kind of mentioned this idea of like what the similarity function is capturing. And I think that's quite an interesting idea because, initially when I was thinking about this, I was thinking usually with clip models, you like have an image and then you have its description, and then you're, trying to make that similar. But another way to train these models would be to like the positives come from they're in the same basket together, and then that way the function doesn't just like capture similarity, it captures like this kind of like we have this relationship together, like we're in baskets together. But then I think with the basket, the training of the models is like, how would you kind of bootstrap the data for that without, again, coming back to that problem where you need to be like Amazon and you have this massive collection of basket data?
Sure. So the idea is you can use a larger model to try and improve sample efficiency. That would be one step. Now, if you're trying to compete with the billions of data Amazon has, you're probably going to have to be creative and try to like go back to like the content based space and try to like really richen up your content based embeddings. Incorporating multimodal will be a great step since these search recommendations, some people don't use that right now. Using multilingual, which as I've noticed is something that even Amazon struggles with, which was a really big surprise that I saw 1 month ago when I was exploring things. And so trying to build better content based embeddings is a way if, say, you don't have Amazon's voluminous data in order to try and level up the playing field. That would be one step. And of course, by trying to figure out what type of information is valuable that way, if you have really good content recommendations, that itself might drive some users and be able to help you sort of like get that interaction data that'll further improve your models. And so obviously it's going to be difficult to go up against Amazon, but most of these retailers that are like trying to build these sorts of models may be more niche or more specific to types of areas. And so they don't have to compete with Amazon everywhere. It doesn't matter what Amazon's pillow data is if you're selling bricks, for example. Like that type of correlation simply isn't going to matter too much for your products. So if you focus on the things that you are trying to sell and try to get really good embeddings and content on that and try to get interaction data on that specific set of products, then it'll be fine. Like if you're a boutique retailer that only like sells 35 different items, it doesn't really matter if like millions of people use Amazon. You just need a ton of data on those 35 products. And you just need to really understand your 35 products really well with your models, and then you should be set. So I wouldn't worry too much about competing with Amazon unless you're literally trying to build the next Amazon, in which case, well, I don't know much about that. I can't really provide any advice.
Yeah, I think this is related to this concept of like, the embedding models, they're between 20 million to 100 million parameters, and like being clever with the training techniques. Like I'm sure at Vody, you have a ton of expertise on like how you train these kind of models, and that's a moat. And I think it's a very interesting kind of startup to pursue for people who've been studying machine learning. And the reason I'm saying this is that we're talking about this kind of how you're doing the similarity, where you're getting the data from, this kind of sampling of the positives and negatives. I think there's so much opportunity to innovate in how you sample positives and negatives and learn these kind of models. And one idea I've been thinking about, and I'm curious if you have as well, is like these kind of like graph neural networks where you have like user and then like, like put it in a basket, and then you also have a graph like these items, they share the same brand. And that could be something as like a clever training technique, right? That maybe you'd uniquely offer.
Yeah, it definitely is valuable. Graph networks have been valuable in trying to like use interaction data in particular. For example, since seeing the sequence of like the products you might use has been something that I think has been historically of interest. Transformers themselves can be considered some sort of graph networks, and that the attention itself is some sort of graph. I do think it's valuable, especially for the interaction data. It's not something that I am particularly strong in, but it's definitely been something that I've been looking at.
Yeah, super cool. Yeah, I do think with the graph nets, I guess, I don't know. It's like because I think a lot about Weaviate. Weaviate was originally a knowledge graph technology, and so this we still have these like cross references between the classes, and so I like to think a lot about how you can maybe send embeddings through the graph to get better embeddings for your particular context. That's kind of what inspires me to think about this kind of graph neural network thing. But so anyway, I think it was a great coverage of getting into the meat of how the models are trained. Maybe kind of a wrapping up topic would be just like what is on the horizon of multimodal that that's immediately in front of you, as well as something that maybe is like 3 to 5 years out.
We probably have different timelines.
I think that having models that understand multimodal, like among text, images, and then maybe domain specific modalities like structured data, clickstream, videos, audio, what have you, that's going to be something that's going to be seen more and more across enterprise AI. Maybe not necessarily academics, since these types of things matter more from a business application. And so you'll see a lot more of that, at least the company's hoping for that. You'll probably also see a lot more of these types of multimodal models be used for generation capabilities. Definitely, there's going to be a lot of interest in the next few months as long as this generative wave continues. But even when all the dust and hype settles, people will realize that being able to use all these different modalities and be able to generate text, like for example, if I don't know, if Amazon or Wayfair want to build a chatbot to like answer customer queries, something like multimodal is going to be very valuable for that. So those are the two areas that, at least I think, that multimodal is going to be very valuable for these types of companies in the next few years. We are expecting tons of adoption of this, and we expect it to completely turbocharge and change the way that people do recommendations. And maybe even off of a stretch, like something like Bing Chat or a ChatGPT plugin, people can simply interact with, say, a chat and be like, ask for a product to be found, and then we can even automate product search so that rather than you having to sift through like 10 products and try to find the right thing, you can just talk to this model and it'll just automatically be able to generate, say, the product that you're looking for, have a simple click button to like pay for it in one click, and then you're done. And so that, I think, is one particularly exciting application of multimodal LLMs. Being able to use like a Bing chat type application in order to like automate large parts of product search, so that, well, I mean, we already have models that can search the web better than a human can. At least that's the idea behind Bing Chat. Why not have something like that that can search for e-commerce products better than a human can, and then probably save a lot of us so much time? So that's something all those things are things I'm really excited about for the next few years.
I share his excitement on that side. I'd say what else I'm excited about is just the ability to actually get any of this done, right? So thank you to our startup friends like you guys, and OctoML offering inference. Like there's really going to be, it's going to be much easier, and the cloud platforms and the investments they're making to do all this work, to use these models, to be able to use these embeddings and get them into production. And I think that's, in the next couple of years, that's one of the things I'm most excited about.
Awesome. And so, just one more thing, picking apart your brain, particularly Stephanie, being CEO and building businesses, I'm really curious how you see kind of the space of open source with this topic. If you think about, like, I'm curious how companies like yours that offer this kind of like model training for particular companies, how you then also think about open sourcing some of the stuff you do, and just how you see that.
Yeah, so super important topic to us. All this work is because of open source, right? So we embrace it, we love it. Right now, we're working on sort of more limited open source academic partnerships, places like that, so that we can make sure we're getting the appropriate amount of feedback and keeping it out there. I think our intention, and as you said, how do things age? So maybe I'll regret this, but our intention would be that as we continue to evolve and release more models, we will make some of them open source. And we're working right now on how we're going to approach that. But for the interim, embracing it heavily because it's advancing our work. As we said, we're using a lot of open source models and using a lot of open source techniques to make these models work for e-commerce. And so we're going to find our way to give back to that. We have great data sets. They're enormous. That, for example, those types of partnerships, so we can help more of that open source work that we use get published, I would say, is our first goal.
That it's so fascinating, like the explosion of open source models. I mean, yeah, it's also interesting with kind of the idea of you could take one of these checkpoints from Hugging Face that comes from Vody, and then you could fine tune it, or maybe you already do that kind of thing. And I know, talking to Brian about unstructured and how they're going to train foundation models for like information extraction from, say, like PDFs and visual documents. This whole emerging space of the open source models is also interesting. I have one more question on that, which is like, there's the open sourcing of the model weights themselves, but then there's also like something that I always like hat tip to Mosaic ML for and respect a lot. What they did is they open sourced this composer library, and so it's implementations of all sorts of efficient deep learning techniques that like like alibi attention or like stochastic path dropout, like all these kind of details of the models. What do you think about open sourcing some of the like kind of like the the tricks of the training that goes in as well, or just kind of model weights?
I think there's room for both in that situation. Now, given that a lot of these innovations, alibi attention, rotary, well, I don't even know if rotary embeddings counts as an innovation at this point. So many models use it, but essentially, I think a lot of that's going to be open source before we even like integrate it to a model, since a lot of the most valuable work in this space has been open source. OpenAI is basically just GPT-4 was like, let's go take everything that's open source available, add to GPT-3, and then make GPT-4 in essence. And they added some of their own stuff, but anything they added was very quickly open sourced by a lot of passionate researchers. And so we are going to say open up that stuff, but by the time we do, my guess would be that there already are going to be multiple libraries out there that do that type of stuff. Like, it wouldn't surprise me if, say, Phil Wong, Lucid Drains, this crazy smart person who like open sources every model. Like, I'm pretty sure like that's still going to be the go-to place to find these types of innovations, no matter what, say, Vody or any other company does. Like, there are open source is always going to lead the way, and really any business is just going to try and combine those things to a model simply because there's tons of innovations, but they all tend to be like one specific area, one specific paper, one specific model. Combining those is where I think a lot of the moat and the opportunity lies.
And to your point, our business very clearly sits in the a lot of great open source work not immediately applicable at a business level, right? And so our business is in taking a lot of this work and making sure that it is enterprise ready, for business applications, which is a sort of extension of that. That's why I said I think we'll probably end up contributing before that on how can we help advance some of the work that we then use.
Yeah, fantastic. Awesome. Stephanie, Gunjan, that was such an incredible coverage of all these topics. I learned so much about training embedding models, all the things, how you're seeing the space. As we're wrapping up, do you maybe have any links, upcoming announcements, things that people listening can use to, keep up with all the work you're doing?
Yes, we are releasing a new web app where you can try our color model. There'll even be some data so that you don't have to prepare your own. And it will be coming on our new website at Vody.com. So definitely check it out. And you can apply to get a link to the API if you want.
Awesome. Thank you so much.
Thanks, Colin. Great.
Thanks so much. Thank you.